Another type of problems occurring in pipe connections are those with branches. Okay, combination of series and parallel connections as the one that you are shown here. So pipe 1 branches into two other pipes 2 and 3, and then merge again to be connected to pipe 4. Now, these are now our equations, or we formulate these equations out of this. And paano ba natin siya na-formulate? Okay? So, to formulate this equation, magandang i-drawing natin yung hydraulic, yung energy gradient. So, the energy gradient, yung original gradient niya, yung original energy ng fluid bago siya pumasok dito ay ganito kataas. Okay? Ito yung energy niya. That's the total energy of the fluid as it enters point A. As the fluid travels from A papunta sa B, nag-uubos na siya o gumagamit na siya ng energy. So there is a vertical drop in the energy of the fluid corresponding to a friction loss HF1. Okay? And then, ito ay nagkaroon ng division of flow. May nagpunta sa pipe 2, may nagpunta sa pipe 3. Pero ganun pa rin, ito-drawing pa rin natin yung energy gradient sloping downward to the direction of flow, papunta from B to C. So, slope. So, this slope now is this slope or this drop in the energy gradient will correspond to either HF2 or HF3. Okay, so, or. Isa lang yung drop ng energy gradient natin, posibleng HF2 or HF3. And then, as it merges at point C, the energy gradient drops further, HF4. So, ang total head loss niya is the head loss from A to D. Okay, yun ang total head loss niya, represented by this vertical distance. Now, how do we formulate the head loss from A to D? So, it is HF1 plus HF2 plus HF4. Okay, that is one equation. Or, HF1 plus HF3 plus HF4. So, dalawa yung equation natin. Pwedeng. So, dapat ito ngayon, from our formula, HF2 is equal to HF3 kasi yun eh. Okay? Isa lang yung head loss dun sa nag-branch. Equal yung head loss sa dalawang parallel pipes 2 and 3. Now, in terms of the discharge, our equation will be, okay, yung discharge at pipe 1 ay nagkaroon ng division na hati sa pipes 2 and 3. So, it is Q1 is equal to Q2 plus Q3. So, continuous ang flow dito, continuous ang flow sa pipe 3, at magme-merge siya ulit para lumabas sa pipe 4. So, Q1 is equal to Q4. Okay? Okay, so, applying the principles we have in pipes connected in series and parallel, we have here a problem. Okay? The problem is to find the discharge in each of the pipes connected as shown. So, the total head loss from this point A through the discharge end E is 15 meters. So, alam nyo na yan, we did not draw the energy gradient anymore. We are going to formulate the equations that relates to this figure. So, if we take F, the friction factor, 0.02 for all the pipes, ano daw yung discharge sa bawat pipe? Okay? So, given naman yung length, diameters of all the pipes connected. So, you see here, the discharge enters through pipe 1. And then, pipe 1 is connected with 2 diameters. So, nagkaroon ng division of flow, 2 and 3. And then, 3 is connected with another pipe, 4. And then, pipe 2 is continuous here. So, ito ay continuous din dyan. And then, the discharge at pipe 2 and 4 merge to discharge at pipe 5. So, yun yung discharge. Okay? So, i-formulate natin yung formula for na appropriate para dito sa figure. So, alam natin that Q1 ay nagkaroon ng division na flow at pipes 2 and 3. So, Q2 plus Q3. Yung pumasok na-discharge sa pipe 1, nahati sa dalawang pipes 2 and 3. Tapos, yung discharge sa pipe 5 ay nanggaling sa nag-merge na discharge sa pipe 4 tsaka sa pipe 2. So, nag-merge yun. So, Q2 plus Q4. Now, the flow at pipe 3 ay continuous na dumaloy hanggang sa pipe 4. So, it is Q3 is equal to Q4. So, that's another equation for discharge. So, tatlo yung equation natin sa discharge. Now, we can also add that Q1 is also equal to Q5 kasi yun din yung pumasok, yun din yung lumabas sa pipe 5. Pwede rin natin idagdag yun. Now, for the head losses, okay, alam na natin that pag yan ay series, ina-add. So, ang series dito ay 1, 2, and 5. So, 1, 2, and 5. Yun ang total head loss. Ano pa yung mga series? Connected na tuloy-tuloy. 1, 3, 4, and 5. Diba? So, 1, 3, 4, and 5. So, that's the total head loss from A to D. And, dahil ito ay HF2, equal yun sa HF3 plus HF4. Kasi, this pipe 2 is parallel to 3 and 4. So, ito yung ating anim na na-formulate na equation out of this figure. Now, so, nakikita nyo class, pagka nagiging complicated at nagkakaroon ng maraming connections, nagkakaroon ng mas maraming equations in terms of the head loss, in terms of the discharge, because there will be division of flow. There will be merging, but there will be division of flow. Okay? So, if you are going to use the friction factor F is 0.02, this is the general equation for finding the major loss. 0.0826 F LQ squared over D to the fifth. This is in terms of Q. Nanggaling ito from the Darcy-Weisbach H friction loss is equal to FL over D Q of B squared over 2G. Now, if we are going to convert those quantities so that we solve for, or the formula will be solved in terms of Q or the discharge, it is 0.0826 F LQ squared over D to the fifth. Now, so we are going to use this. What we are going to change are the subscripts lang. For example, HF2, okay, from equation 6, the friction loss at 2 is equal to the friction loss at 3 and 4. Okay, ito kasing dalawang ito ay parallel. So, substituting the value for the Darcy-Weisbach for the friction loss at 2, subscripts, yung lang subscript ang mag-change kasi 2, 3, and 4. So, puro 2, 3, and then 4. Dahil yung 0.0826 F will be repeated lang for all these quantities, kakancel na siya. Pwede niya siyang i-cancel. Kasi pare-pareho lang naman ng friction factor F. So, cancelable, pare-parehas na 0.0826. So, i-cancel na natin. The formula is left with L2 Q2 squared over D2 to the fifth, and so on. Then, we substitute all the given values. L2 and D2 are here. L3 and D3 are given. L4 and D4 are given. So, this will be an equation in terms of Q2, Q3, and Q4. Okay? So, going back to the figure, the pipes 3 and 4 are connected in series. Therefore, yung discharge sa pipe 3, yun din yung discharge sa pipe 4. So, we have the equation Q3 is equal to Q4. So, nung substitute natin, yung 4, sinubstitute natin ng Q3. Remember, in algebra, like terms can be added. So, Q3 squared and Q3 squared are like terms. So, we have now one equation with two unknowns. Okay, Q2 and Q3. So, solving for Q2 in terms of Q3, it is 1.54 Q3. Substitute natin ngayon ito sa equation 1. So, remember that equation 1 is Q1, yung pumasok sa pipe 1 ay equal sa Q2 plus Q3. Okay? But we know that Q2 now is in terms of Q3. Substitute natin dito, 1.54 Q3 plus Q3 is 2.54 Q3. So, we know that Q1 is equal to Q5. Okay? So, we have equation in terms of two unknowns. So, nababawasan na yung unknowns. Kanina, 3 yung unknowns natin. Now, here, from equation 5, the relationship of the head losses, the total head loss 15 is equal to the loss at pipe 1 plus HF3, HF4, and HF5. These are series. These pipes 1, 3, 4, and 5 are in series, kaya siya ay added, equal to 15. Now, so in terms of the Darcy-Weisbach, again, from 0.0826 FLQ squared over D to the fifth. So again, ito na lang yung natira. Okay? HF1 in terms of Q1, HF3, which we have computed previously, kanina. Ito yon. Okay? Q3, and then Q5, ayun. Now, we know that Q1 is equal to Q5. Yung pumasok sa Q1, yun din ang lumabas na discharge sa pipe 5. Kaya, pwede natin silang i-combine. Okay? So, yun. Na-combine na natin. We have this one in terms of Q1 and Q3. Okay? Q1 in terms of Q3, and then we solve for Q1. Q1 is here. Q1 is 2.54 of Q3. Okay, ito. Okay, so yung Q1, sinubstitute natin yung Q3. So, isa na lang yung unknown. So, Q3 can be solved. 0.0139, which is the same as Q4. Okay? So, from here, Q2 is 1.54 Q3, and Q3 is 0.0139, Q2 is 0.0214, and Q1 is 2.54 Q3, all in terms, kasi nakuha na natin yung Q3, kaya masosolve na natin all other discharges through the other pipes. So, nakuha na natin ng Q3, Q4, Q1, Q2. Okay, Q1 is also equal to Q5. So, ito yung discharges. Okay, these are the problems asked in our sample. Find the discharge through each pipe. Para ma-check nyo kung tama answer nyo, you can choose any of the formulas that we have formulated. So, tingnan natin dito. HF2 ay nakaparallel sa dalawang pipes that are in series, pipes 3 and 4. So, ito yung na-formulate natin kanina, that the friction loss at pipe 2 is equal to the sum of the losses at pipes 3 and 4. So, substitute natin yung mga nakuha nating discharge. Discharge sa pipe 2, 0.0214. Discharge sa pipe 3 is 0.0139. Discharge sa pipe 4 is the same, 0.0139. The equation is equal. So, yung makukuha mo dito, equal dun sa sum na yon is 8.79. Now, if you notice class, medyo hindi ako, I did not rely on answers that are in 2 decimal places kasi pagka chinek mo yan because of the very small quantities, hindi mag-i-equal ito. So, you have, I advise you to answer as much as, for small quantities, as much as 4 decimal, for 10,000s. Okay, as much as 10,000s para mas makita nyo yung equal values niya. So, 8.79 is equal to 8.79. The total friction loss at pipe 2 is the sum of the friction loss at 3 and 4.